Good morning, dear students. Today we are going to learn about measurement. We all know that the measurement is a process of comparing an unknown quantity with a known standard quantity of the same kind. Yes, I repeat, measurement is the process of comparing an unknown quantity with the known standard quantity of the same kind. Okay, so what does it mean? Let us talk about it. Suppose you want to know what my height is. My height is an unknown quantity. You have no idea how much is my height. But if I ask you what is the length of a 1 meter scale, then you will obviously say it is 1 meter. Yes. So you know that the length of a 1 meter scale is a fixed known quantity. It is a fixed standard quantity. The length of 1 meter will not vary from place to place. It remains same everywhere. So if I compare my height with the length of the 1 meter scale, let us suppose my height is twice the length of the 1 meter scale. Then it means my height is 2 meters. Here I am comparing my unknown height with a known standard length, that is 1 meter. You got it, yeah? Okay. So, what is measurement? The process of comparing an unknown quantity with a known standard quantity of the same kind. Remember, of the same kind. For example, my mass is unknown to you. You don't know my mass. But if I ask you what is the mass of 1 kg block, obviously you will say the mass of 1 kg block is 1 kg. Yes. There, 1 kg block, mass of 1 kg block is a known quantity. My mass is unknown quantity. Can I use the mass of 1 kg block to measure my height? No, we cannot do that. Although 1 kg mass, the mass of 1 kg block is a known quantity, I can't use that to measure my height because my height is another quantity. Height and mass are different quantities. To measure unknown height, we use unknown length, that is meter scale. To measure unknown mass, we use unknown standard mass, that is a 1 kg block. I hope it is clear now. Yes. So if you want to measure unknown mass, you have to compare the unknown mass with unknown mass. Yes. If you want to measure length of something unknown length, then you have to compare the length of the body with unknown standard length. Okay. Now, so again, measurement is the process of comparing an unknown quantity with a known standard quantity of the same kind. We hope we are clear now. Yes. Okay. Now, quantity. When you talk about quantity, there are two kinds of quantities. Okay, one is non-physical and another is physical quantity. When we say I love you or I hate you, you can't say how much you love someone or how much you hate someone because these quantities cannot be measured. Such quantities are called non physical quantities. On the other hand, there are certain quantities that can be measured, for example, length, mass, time, area, volume, pressure, etc. So, such quantities that can be measured are known as physical quantities. Okay. For example, if someone asks you how much is your mass, you can say that your mass is 40 kg or 50 kg or 60 kg depending upon how much your mass is based upon the measurement. Yeah. When you measure your mass, you will get the you'll know the exact value of your mass. Okay. So physical quantities, it is again divided into two types: fundamental physical quantity and derived physical quantity. So fundamental physical quantity, fundamental means basic, that does not depend upon other quantities. Okay, so fundamental physical quantities are those quantities that do not depend upon other physical quantities. They are the basic quantities. They are independent of other quantities. Okay, for example, length, mass, time, etc. are fundamental quantities. Okay, so if someone asks you why mass is called a fundamental quantity, what should you say? Okay, you just need to say that mass is called a fundamental quantity because does not depend upon other quantities. Yeah, if I want to measure my mass, all I need is a balance. I don't need to see the time. I don't need to measure my height. Yes, my mass does not depend upon time or my height. So mass is a fundamental quantity. Similarly, time is also fundamental quantity. To measure time, you don't need to measure mass. You don't need to measure height. You don't need to measure any other things. Just measure time. Yes, the time is a fundamental quantity. Okay. Now let us talk about derived physical quantities. Now, derived physical quantities means, okay, derived physical quantities are those quantities that depend upon other quantities. Okay, derived itself means that it is dependent upon others. It is derived from something else. Okay, so derived physical quantities are those quantities that depend upon two or more fundamental quantities. They are not independent. I repeat, these quantities are not independent, they depend upon other quantities. For example, when we talk about area, now you know that area of a rectangle can be expressed as area equals to length of the rectangle into breadth of the rectangle. Here, area depends upon length and breadth of the rectangle. Length and breadth are two fundamental quantities. Since area depends upon two other fundamental quantities, therefore area is a derived quantity. Similarly, volume is a derived quantity because volume depends upon length, breadth, and height. So if someone asks you what kind of quantity is density, you can again say density is also a derived quantity. As you know that density is defined as mass per unit volume of a substance. Since density depends upon mass and volume of a substance, density is also a derived quantity. In this way, we can say that area, volume, density, speed, velocity, acceleration, force, work, power, pressure, these all are derived quantities. Okay, so suppose someone asks you why is power called a derived quantity? All you need to say is that power is called a derived quantity because power depends upon work and time. You know, power is defined as the rate of doing work. P equals to W upon T. Power equals to work done upon time taken. Clearly, power depends upon work and time, hence, power is called a derived quantity. Okay, this much for today. Thank you.